solution h1 is equal to 6 by 5. All right. Okay, 6 by 8 andre we can simplify 3 by 4, I guess, right? All right, correct. Next, 6 by 11, 3 by 7, 6 by 17, 3 by 10. Yes. So this is the answer, correct answer to this question. All right, let's move ahead. Then this is again a note. Right, so let A comma B be real and positive and unequal numbers. All right, and let A, G and H, right, be the, so A, we know that capital A stands for the arithmetic mean. Okay, so this is B, A for arithmetic mean, G for the geometric mean, and H for the harmonic mean, right, of A and B respectively. Right, then we have some points to remember related to the relationship between A, B, capital A, capital G and capital H. Right, so this is going to imply that there is a relationship. G square is equal to capital A into H. So this actually means that A comma G comma H, right, they are in the geometric progression. Always the A, G, H in geometric progression. And also we have another relationship, that is A is the largest, then you have G, then you have H. Okay, right, then all right, let's go to the another point under this note. This is also equally important. So here, all right, let's say if A1 comma A2 comma A3 dot 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 up to AN are n positive numbers, right, then once again the arithmetic mean of those numbers is always greater than or equal to the geometric mean of them, again greater than or equal to the harmonic mean. Okay, so how do you find out the arithmetic mean? I can try to write A1 plus A2 plus dot 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 plus AN whole divided by n. This is the arithmetic mean. This is always greater than or equal to, geometric mean is A1 into A2 into A3 into all the numbers up to AN whole raised to the power 1 by n. Okay, so everything has to be raised to the power 1 over n to get the geometric mean. So this is always greater than or equal to the harmonic mean of n numbers, which is n divided by 1 over a1 plus 1 over a2 plus dot 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 up to 1 over a in the denominator. Okay, now let's move on to the next point under the same note. That is, if capital A, comma G, comma H are the arithmetic mean, the geometric mean, and the harmonic mean of three numbers now, A, comma B, comma C, right? Then there is one equation, right? Then, right, A, B, C are the roots of the following equation. Then, okay, we can write then A, comma B, comma C are the roots of the equation denoted by x cube minus 3 times the arithmetic mean into x square plus 3 times g cube x divided by h minus the g cube equals to 0. Okay, so this is the equation for which we have the roots, or roots as a comma b comma c, right? For those numbers, capital A comma capital G comma capital H are the arithmetic, geometric, and the harmonic means respectively, right? For three given numbers, if you know the arithmetic, geometric, and the harmonic, then you can write an equation x cube minus 3 capital A times x square plus 3g cube x into x divided by h minus g cube equal to 0, solving which you get the ABC once again. All right, okay. Now, let's move to a question based on these concepts. If A, comma G, comma H are the AM, GM, and HM of two numbers A and B such that a to the power x is equal to g to the power y, that is equal to h to the power z. Right? Then find the relationship of x comma y and z. Okay, so this is the question. Let us start the solution by what is given. They have given that a to the x is equal to the geometric mean raised to the power y, that is also equal to the harmonic mean being raised to the power z. Okay, let's call this as a constant k. Okay, now I can write this. This implies the a is equal to, a can be found as k to the power 1 by x, right? And also I can find the g is equal to k raised to the power 1 by y, and I can also write h is equal to k to the 1 by z. Right, now already we know one thing about A, G, and H, because A, G, H are the arithmetic, geometric, and harmonic means of the two numbers A and B, right? So this implies, since they are the a, g, comma h of two numbers, it actually, they follow the geometric progression, right? So we know that g square is equal to a into h. Okay, I can replace the g. What is g? G is equal to k to the power 1 by y squared is equal to a, what is a? K to the 1 by x, and h, which is equal to k to the 1 by z, right? I can try to write this. This implies k to the power 2 by y is equal to the k to the power 1 by x plus 1 by z. So since the uh, k is common on both sides, I can actually remove that, right? I can simply write 2 by y is equal to 1 by x plus 1 by z is the required relationship between x, y, and z, right? But you see, if I have something like this means it is, right? It is the arithmetic progression, right? 2 by y is equal to 1 by, so 2 times something is equal to first term plus last term. So that actually means that 1 by x comma 1 by y comma 1 by z is in AP, right? You may find this as a answer, or you may find this as an answer in the question, right? One of the answers, so we can tick that. All right, next question. Okay. If harmonic mean of the two numbers is 4 and relationship between their arithmetic mean A and the geometric mean G is 2A plus G square equal to 27. Okay, 2A plus G is equal to 27. So this is the relationship between A and G of the same two numbers. HM is given, so H is equal to 4 and G square plus 2A equal to 27, right? Find those numbers. Okay, this is the question. Okay, the two numbers are, first number is 3, second number is 6. All right, next. Okay, we'll move on to the next topic here. This is the sigma or the summation, okay, notation. Right here, basically it is a mathematical notation which actually is used to represent the sum of similar terms. Okay, for example, if at all I want to write the sum of the term which uses a nth term as un, okay, if say un is the nth term of a series, then the sum of the series that series can be represented by using the summation notation, that is summation maybe n is equal to 1 till some kth term. I have, right, k different values to be calculated, k different terms to be calculated. To put up the sum, then this will be simply un, right, like u1 plus u2 plus u3 plus u4 up to uk. Until k terms I want to find them, right? Example, you can write summation n is equal to 1 to 9. It is n itself. This is basically, put n equal to 1, it is 1 plus 2 plus 3. Put n equal to 9, you have until 9. Okay, all right. Now, let us look at the various properties of the sigma notation, right? The properties. Okay, the first property is simply the expansion. Summation say r is equal to 1 till n. Tr should be equal to, r has to be replacing with 1 till n values, like t1 plus t2 plus t3 plus t4 plus t5 and so on, right? I need to substitute the various values to get this. So tr, this is equal to capital T1 plus T2 plus T3 plus T4, T5 plus the last value, which is equal to Tn, right? Where Tn is the general term of the series. We can simply write like this. This is the property number 1. Okay, then property number 2 is relating the sum or difference inside a summation. So this is r is equal to 1 till n. So tr plus or minus, say another term, say tr dash. This can be simply replaced by two summation. Summation r is equal to 1 to n. So r is equal to this is 1 to n. It is tr plus or minus the same, r is equal to 1 to n tr dash. So this property is called as a distributive property under addition and subtract. You can distribute. The summation, which was one summation in the beginning, can be distributed into two parts, right? So you can distribute. Okay, this is one important property, but there is another version of the same property that's also pretty much important. That is, what if you have the multiplication instead of, right, this addition? So that is third one. So if you have summation of r is equal to 1 to n, let me say I have a product tr into tr dash, right? Can you write this is equal to summation r is equal to 1 to n tr into summation, one more, r is equal to 1 to n tr dash? Can you write? No, this is not equal. Okay, so that is the next property. You cannot distribute the summation or the sigma operator whenever you have multiplication in place. Okay, then again, this is not distributive in the division as well. So summation r is equal to 1 to n. If I try to write something like tr divided by tr dash, definitely this is not equal to the summation r is equal to 1 to n tr divided by summation r is equal to 1 to n tr dash. It's not equal, right? Again, this property states that the sigma is not distributive, right, when you have division in place. Okay, then this is a linearity property, so this is fifth one. So if I try to write summation r is equal to 1 to n a times tr, this can be simply replaced by, you can move the constant outside. This is r is equal to 1 to n tr. Right? Then sometimes we have a special case coming up where we have double summations. One is for I, say I is equal to 1 to n, j is equal to, right, 1 to n. This is tj, ti. All right, this actually can be replaced by, so this is j is equal to 1 to n, right? Write the tj. This is the first summation into the second summation, that is I is equal to 1 to n ti, right? You can definitely write like this because I and j are completely independent. Okay, let's write some more points over here. That is, I'll write point number 7. So if I try to write the summation, that is r is equal to 1 to n, this is f of r plus 1 minus f of r. All right, so this is equal to, if at all we try to substitute something, if what we want to find an answer to this, this can be simply written without the summation. So that will be f of n plus 1 minus f of 1. Okay, that's the first one. Point number 7. Let's go to the next one. This is, if at all we write summation r is equal to 1 to n, I write f of r plus 2 minus f of r. If at all you want to calculate this summation, then this can be directly replaced as f of n plus 2 plus f of n plus 1 minus f of 2 minus f of 1. Okay, very important properties. Then we have few more properties to use. This is the 9th one. If we write summation r is equal to 1 to n f of r plus k minus f of r is equal to, I can simply replace this as the summation m is equal to 1 till k f of n plus m minus the summation m is equal to 1 to k f of n. Then we have several properties. We can use any one of them as per the requirement in the problem. All right. So next one, summation r equals to 1 to n f of this is f of 2r plus 1 minus f of 2r minus 1 can be replaced without summation as f of 2n plus 1 minus f of 1. The next one, that is summation r equals to 1 to n f of 2r minus f of 2r minus 2 is equal to f of 2n minus f of 0. All right. So this will be used to find out many of the standard, what you call, standard sums. Okay, so let's try to write the standard results. The first standard result is a sum of n natural numbers. Sum of n natural numbers is nothing but this is 1 plus 2 plus 3 up to n. How do you write this? This is nothing but summation of n, right? So summation of n is nothing but, we already know that sum of first n numbers is replaced by n into n plus 1 divided by 2, right? So this is the sigma notation and this is the answer which we know from arithmetic progression, right? You can directly write the summation n as n into n plus 1 by 2. So that is important. Whenever I see summation n, I should be able to recall this n into n plus 1 by 2 and I should. Okay, next. Next one. This is sum of n odd and odd natural numbers. So the odd natural number represents 1 plus 3 plus 5 plus this up to n terms, right? So till n terms. So you can see that this is this can be written as, okay, let's try to give a notation first. So notation in the sense, I should be able to represent this as a even odd number. So when I put n equal to 1, I should get 1. When n equal to 2, second number is 3. The third number is 5. So you can see that this is nothing but summation of 2n minus 1, right? Put n equal to 1. What happens? 2 into 1 minus 1. So that is 1. When you put n equal to 2, the second term is 2 into 2 minus 1. So 3. Then when you put n equal to 3, 2 into 3, 6 minus 1. So that is 5. So you are taking the sum of numbers like that up to any nth number. Okay, so this comes to be equal to simply n square. Right? That is the answer. Just check. First two numbers, 2 square. First three numbers is 3 square. It's a 9, right? 5 plus 3. First four numbers is 4 square. Right? That is 16 and so on. So that is the answer. So first odd numbers. Sum of the first n odd numbers is nothing but n square. a standard result, then let's move further. Sum of the squares of first n numbers. N natural numbers, that is 1 squared plus 2 squared plus 3 squared dot 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 plus n squared. This is nothing but summation of n squared. There is actually a formula which can be derived, but as of now I'll write it directly. So that is n into n plus 1 into 2n plus 1 divided by 6. Okay, similarly, let's write a few more terms. So the next one, what if I want to write 1 cube plus 2 cube plus 3 cube dot 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 up to n cube? This can be written as a summation of n cube. So the standard answer for summation of n cube is n into n plus 1 by 2 the whole square. Okay, so actually I can rewrite this as summation of n the whole square, because summation of n, you can see that is nothing but n into n plus 1 divided by 2. All right, next part. What if I want to write 1 power 4 plus 2 to the 4 plus 3 to the power 4 up to n to the power 4. So this is nothing but summation of n to the power 4. Right? This is equal to n into n plus 1 into 2n plus 1 into 3n square plus 3n minus 1 whole divided by 30. Okay, so there is a plus 1 in the middle. This is 2n plus 1 into this. So lastly 3n square plus 3n minus 1 whole divided by 30. Okay, what kind of questions that might come over here? Let's see few of the examples. So the next find the sum up to n numbers of 1 square plus 3 square plus 5 square, right, up to n terms. So this is the question. So whenever a series is given to find such a sum, right, first objective should be writing in the nth term, right? So this is, you can see that it's a square and it is nothing but 1 square, 3 square, 5 square. 1, 3, 5 can be simply written as the odd numbers, which is 2n minus 1. There is a square. So this is 2n minus 1 the whole square. Okay, right. So how do I, what if I don't know this, right? I can still see that the 1, 3, 5, etc. is in AP, right? You find the AP and square it, still you get the same term, right? So I'll just prove that. So let me try to write the Tn. Tn is equal to, there is a square. What is the first number? A plus, I need nth term, so n minus 1, right? So 1 plus, I have to write the n minus 1 into this difference, that is 1, 3, 5, difference is 2, the square. So when I write a square, it is no more AP. But you see that the terms 1, 3, 5 are in AC. So if you simplify this, 2n minus 2 plus 1. So that is, this simplification is 2n minus 1, and a square is there outside. So that square I write here. So actually you are getting this back, right? Either you know how to write a odd number, right? Or you derive it. So this I will try to expand now. Okay, so the 2n minus 1 will be trying to expand as follows. Right, so that is 2n square. So 2n into 2n is 4n square minus 4n plus 1. So this is the Tn. Now what I want the summation, right? So the sum, I'll write sum is equal to summation of Tn. So that is summation of 4n squared minus 4n plus 1. So what I can do here, I can apply the summation into this. So 4 times summation of n squared minus 4 times summation of n plus summation of 1. Okay, now we already know that's why we wrote the term summation n square, etc. in the previous case, right? So just now we have written what are the values of summation of n square, summation of n cube, etc. You can see all the values over here, right? So pick up from there whatever you require that you need to substitute. So let's substitute that now. So this is going to be, what is n squared? So if I want to write a n square, the summation of n square has to be, right, 4 into the n square summation is nothing but, you can look the equation. Equation says it is n into n plus 1, n into n plus 1 into 2n plus 1 divided by 6 minus 4 times summation n is nothing but n into n plus 1 by 2, and summation of 1 is nothing but n itself. Okay, 1 plus 1 plus 1 plus 1 n times is n. All right, now let us try to simplify this and get an answer for this. What we can do here, let me try to take n by, this is, okay, let me take a n by 3 common, because I can see 3 okay, this gets cancelled. So this is 2 into 2, right? This is 2 times this 3 times. Okay, so now I can see n by 3 common. Let me take this out. N by 3, if I take out, I have n plus 1 into 2n plus 1, right, into 2. So n into 2n is 2n square. 2n square into 2n becomes 4n square. Okay, first term. Then I multiply n into 1 is n. 2n plus 1 is 2n. 2n plus 1 is 3n into 2. So that is 6n plus 6n. Then 1 into 1 is 1 into 2 is a 2. That is the first term, right? For the second term, the denominator is 1. I have to make it 3 by multiplying it by 3 to the numerator. So numerator becomes 2 into 3, 6 aಗುತ್ತೆ. This is 6. So 6 into n is n square. So minus 6n square. There is a 2n into 1. 6n into 1, which is 6n. So this is, okay, n has gone out. Sorry, n is outside. So I don't have to write a 6n square. It is simply 6n. So en ideyalla idu horagade hogide. I have written it as a common. All right. So you don't have to multiply that. So simply write it as 6 into n is 6, and 6 into plus 1 is 6. There is a minus outside, so minus 6. Now I have a n here. This n has gone out. by 3 has gone out, n by 3, so I need to multiply by 3 to this to get a common denominator, so I have a plus 3. Okay, that's what we need to simplify now. So this is n by 3 into, so this is n by 3 into, so we have 4n square as it is, 4n square into 4n square, then 6n minus 6n will cancel. This is plus 2 minus 6 plus 3 is a minus 1. Right? Is the required answer. N by 3 into 4n square. Now you can see there is a power 3, n cube is there numeratorly. N into 4n square is a n cube. Right? We have n cube term. So this is the answer. All right, let's solve another problem of the same type. Find the sum up to n terms. This is the equation. This is the series. The series is simply 1 into 2 into 3 plus 2 into 3 into 4. So the dot is actually a multiplier. Okay, plus 3 into 4 into 5 dot 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 up to the last term, right? Okay, nth term, right? That's already it is mentioned in the question, so we don't have to write an n term, right? So this is up to n terms.